Welcome to video 2 for section 1, net ionic equations. What we are going to be looking at today is the decision tree, so please make sure that you have your decision tree in front of you. This is a tool that we can use to decide whether something should be written as ions or not as ions. And we're going to start right here with this question. Is this substance an acid, a base, salt, or other? And the other is going to be anything that is not an acid, a base, or a salt. So an acid is anything that begins with H. A base contains hydroxide ions. If you remember, hydroxide is OH minus. Salts are going to consist of a cation and an anion, so a positive and a negative ion together. And others could be anything from elements to different covalent compounds like CO2, which is a gas. So if we find out that our formula begins with an H, if it is an acid, we go to A on our decision tree. So right here is A. Is it a strong acid? And this worksheet lists the strong acids as sulfuric, chloric, perchloric acid, nitric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. If it's one of these 1, 2, 3, 4, 5, 6 acids, we break it up into its ions. And they show you how H2SO4 becomes 2H plus and SO4 minus 2. If it's not one of these 6 strong acids, it does not break up. So HNO2, nitrous acid, stays HNO2. If we decide that we have a base, which means it has OH in it, hydroxide, we go to B on our decision tree. So is it one of these 1, 2, 3, 4, 5 strong bases? Sodium hydroxide, lithium hydroxide, potassium hydroxide, barium hydroxide, or calcium hydroxide? If it is yes, we break it down into ions. So NaOH, sodium hydroxide, becomes Na plus and OH minus. If not, it stays written as is. So FeOH3, ferric hydroxide, stays FeOH3. If it is salt, we go down to S here with our soluble salts. We have to look at what is called a table of solubilities. And that is on the back of our decision tree. So let's turn our paper over. And if we look, here we have a solubility chart. With this solubility chart, it tells us whether a salt is soluble or insoluble. So down along the left-hand side, we have our cations. If you remember, cations are positive ions. And across the top, we have the names of many of our anions. And those anions are all negative ions. Many of them are polyatomic, like acetate and carbonate. So with this, we look at our cation and anion pair. So if we have aluminum acetate, we see an S in the box. S stands for soluble. And let's write that down here at the bottom. Soluble. And that means that it breaks into ions. So aluminum acetate, which is AlC2H3O2 3, is going to break down into Al plus 3 and 3 acetate ions, each one being minus 1. So aluminum plus 3 C2H3O2 minus ions. That's because it is soluble. If we look at something like barium carbonate has a P in it. It's partially soluble in water. Well, for our purposes, anything that is other than S on this table is going to be insoluble. So anything other than S does not break down or break into ions. So an example of that would be barium carbonate, BaCO3. It has a P, so it stays BaCO3. So if something is not on this sheet or on the front on our decision tree as an acid or a base, we're going to consider it an other. So for example, carbon dioxide, hydrogen disulfide, the element carbon. Those are all examples of things that do not fit into an acid, base, or salt. They would be considered an other. So how does this all fit together? So we have this example worksheet, and this goes through and tells you how to break things up into ions, or which substances do not become ions. So if we look down here in our instructions, we're going to start here, and we're going to go over a couple of these, and then you can try the rest and check with your learning facilitator. So barium hydroxide. We go back to our decision tree. If we look, we ask ourselves, is a substance an acid, a base, a salt, or other? Well, barium hydroxide has hydroxide in it, so it's a base. We go down here, is it a strong base? So we have sodium hydroxide, lithium hydroxide, potassium hydroxide, barium hydroxide, and calcium hydroxide. So yes, it is a strong base. So we have to break that up into ions. So on our worksheet, I'm just going to write strong base. And then I'm going to break this up into ions. And sometimes it helps if you have a charge card, if you're a little bit weak on your polyatomic ions. So barium, if we look on our periodic table, is +2, and OH we know is -1, and we have two of them because of the 2 on the outside of the parentheses, so we have Ba +2 and 2OH-. If we look at CuCl2, copper 2 chloride or cupric chloride, well, we start here. Is it an acid? Does it begin with H? No. Does it contain hydroxide? No, so it's not a base. Is it a salt, a cation and an anion? Well, yeah, it is. So if we go to the back of our sheet, here's copper 2, here's chloride, and there's an S in the box. Well, if we look at our notes down here, we see that S means soluble. It breaks into ions. So on our worksheet, this is a soluble salt. So we end up with Cu +2 and 2Cl-. Our next example, NH3. NH3 does not begin with H, does not contain hydroxide. There's no cation anion because N and H, that's a covalent compound. It's not ionic. So it must be an other. So all we have to do is write other. Do not worry about molecular liquid, molecular gas, or insoluble element. Just write other. Others, nothing happens to. And we'll do one more together. H2SO4. Well, it starts with H, so that means that it is an acid. We have to make sure if it's strong or weak. If we look, it is one of the strong acids. Strong acids, if we follow the decision tree, means that it breaks up into ions. So we can see that there's a sulfate ion here, and there's an H2. Well, we know H is +1, so there's 2H+ and an SO4, and that charge is -2. If you have any questions, please see the learning facilitator in the class. He will be happy to help you if you have questions. Otherwise, please go through the problems on the bottom and the back, and then check your answers with the worksheet at the front of the class.